Welcome, Algebra 1, to absolute value equations, which I know this is not chapter 2, but this is going to be 3-7. But it's still equations, so we're bringing it into this unit. So absolute value. So what is absolute value? We have talked, or you guys have, I'm sure, heard of what absolute value is, so let's just talk about it together. The absolute value of any number is the distance. Hold on. I got a new pen. I got a whole new pack, so when I'm using a new color, it's like, okay, so is the distance, that number is away from 0 on the number line. So let's look first at the absolute value of 5. So the absolute value of 5, if I'm looking at that one, that's saying it's 5 units away from 0. So that would be 1, 2, 3, 4, 5. Now, no matter what direction you're going in, distance is always positive. So the absolute value of 5 is equal to 5. It's 1, 2, 3, 4, 5. Now, let's look in the other direction. The absolute value of negative 5. So the absolute value of negative 5 is just going in the opposite direction. So it's going 1, 2, 3, 4, 5 in the opposite direction towards the left, which is still a positive 5 units. So whatever direction we're going, like let's say I go outside my house and I turn right and I run a mile. Okay, so I ran 1 mile. Let's say I go in the other direction and I turn left and I run a mile in that direction. I didn't just run a negative mile. That would be terrible. I think that's what I do now. But distance is always positive, no matter what direction you're going in. And so absolute value, same thing, is always positive. So the absolute value of negative 5 is also positive 5. So these are the same answers. So an absolute value expression will always equal a positive number. So we have 3 steps to solving an absolute value expression. So what I'm going to do, I'm going to write the steps out, and I'm going to solve number 3 while we're writing the steps, just so you guys can kind of see everything. Okay, so our first step is to, again, new pen, new color. Okay, first step is to get the absolute value expression all by itself on one side of the equation. So get the absolute value expression all by itself on one side of the equation. Now, before I do anything and do it like anything with my example 3, let's fix that E. With absolute values, the only thing that's really different with that is they're not like parentheses. We can't distribute to them. So we never distribute to an absolute value expression. We always undo whatever's being multiplied by dividing it. So let's make note of that. Do not distribute to an absolute value expression. Okay, so let's look at, like I said, let's look at number 3. So first thing, there's my arm. Okay, first thing is getting the absolute value expression all by itself. So I like to see what's my absolute value expression. And that is the x plus 2 part. So we look and see what's on the other side, what's on the same side of that on the equation, and it's the -3. So what I want to do first is I want to move that -3 to the other side of the equation by adding 3 to both sides. And so when I do that, I get the absolute value of x plus 2 equals 12. So is my absolute value expression now all by itself on one side of the equation? And yes, x plus 2 is the only thing on the left side of the equation, so we are good. We can move on to step 2. So step 2 is to split into 2 equations. And the reason we do that is we want to take into account the positive answer and the negative answer. So we're going to split into 2 equations. So one where the answer is the same sign, which it should always be positive when it's equal to, when the absolute value is equal to this number, it should always be positive. If it's not positive and it's negative, we need to look at that and something's wrong. So we'll talk about that. And then the second equation is going to be answer is the opposite sign, which it should be negative. So we're going to split this into 2 different equations. One where it's x plus 2 equals the positive 12, and one where it's x plus 2 equals the negative 12. So we're taking into account both the positive direction and the negative direction for distance. Now, one thing, again, that's super important for absolute values, we do not change what's inside the absolute value symbols. So let's make a note of that. Do not change what is inside the absolute value symbols. Okay, so that means that the x plus 2, that's not what changes. What it's equal to is what changes. Notice how I mentioned it's the answer is the same sign and the answer is the opposite sign. And so from there, our last step is to solve each equation separately. Separately, it's a really hard word to spell. I Googled how to spell it. Separately. Honestly, I have to Google it every time. Okay, so that means we're going to solve each equation separately. So I would just get x by itself. I would subtract 2 from both sides. And I get x equals 10. And then now with that solved for, I move on to my next one. Subtract 2 from both sides. And I get x equals -14. And those are my 2 answers. So that is what my final answer would be. Now, why do we have 2 solutions? So let's actually talk about that for a second. So what I want to do is I am going to plug those in. And I'm just going to plug in from x plus 2 equals 12 because that's not changing like anything. That's just moving one thing to the other. So if I plug in 10, so that would be 10 plus 2 equals 12. I just plugged in 10 for x right here. So 10 plus 2 is 12. The absolute value of 12 is 12. That works out. Okay, let's try -14. So -14 plus 2 equals 12. -14 plus 2 is -12. And is the absolute value of -12 positive 12? Yes. The absolute value of any negative number is always positive. So you will always have two solutions for an absolute value equation. So let's make that note too. You should always have two solutions. Okay, so let's go back up to number 1. Let's try that one together. So first thing, we want to get the absolute value expression all by itself. Now, in this one, and the reason I didn't do this one first, is because the absolute value expression is already by itself. So all we have to do is go on to step 2, which is splitting it into our two equations. So one of them is 4x plus 2 equals the positive answer, and the other one is 4x plus 2 equals the negative answer. Oops. And now I can just solve those separately. Now it's just like two different problems solving an equation. So I'm going to start here. I undo addition and subtraction first. So I'm going to subtract 2 from both sides. And I get 4x equals 34 minus 2, which is 32. Divide both sides by 4 to get x by itself, and I get x equals 8. So that's one of my answers. Now I move on to my second equation. Subtract 2 from both sides, and I get 4x plus 2 minus 2 is 0 equals negative 36. Divide both sides by 4. Negative 36 divided by 4 gets me negative 9. So I have my two solutions, 8 and negative 9, and that is it. Okay, so I want you guys to look at 2, and I want you guys, very similar to number 1, I want you guys to try number 2 on your own. So I want you guys to just start with the first step, or maybe the second step. So start there. What would you do here? And then come back to check your work. So pause me here now. So first thing you should have done is recognize that the absolute value expressions are already all by itself. So our first step is to split it into equations. One where it's equal to the positive 17, one where it's equal to the negative. And now my second step, or my third step technically, go ahead and do that part on your own. I'm just going to start with the first equation. And so I solved for x. So I solved my first equation, got x all by itself. So I added 5 to both sides, divided both sides by negative 2, and I got my first solution to be x is equal to negative 11. So continue on if you haven't already and do that for the second equation. So I solved for my second equation and I got x is equal to negative 11 and x is equal to 6. And that is it. Okay, so let's move on to 4. 4 is very similar to number 3. So what I want you guys to do, I want you guys to, on your own, pause me here, and I want you guys to think about what would be your first step in solving this absolute value equation. So hopefully your first step, your first thought process there was get the absolute value expression all by itself. And so what we do is we subtract the 2 from both sides. Now, at this point, I want to look to see what my answer is. My answer is positive, just like it was over here and here and here. So we are good to move on and split this into two equations. So go ahead, again, pause me here if you've not already finished the problem, and solve for your two solutions. So you guys can continue on with the rest of the problem. So it was a simple one-step equation for each one. X minus 3 equals 2. X minus 3 equals negative 2. I added 3 to both sides, and I got 5 and 1 for my solutions. And that does it for number 4. Okay, so let's move on to number 5. So we have 3 times x plus 7 equals 21. Now remember, in our steps to solving absolute value equations, our first step is to get the absolute value expression all by itself on one side of the equation. And remember my big takeaway there, do not distribute to an absolute value expression. So on number 5, a lot of you guys might be tempted to distribute that 3. Now, it might work sometimes, but it's not consistent because it's not accurate for us to do. So instead, what I want to do to get that absolute value expression all by itself, that's 3 times that whole thing. What I'm going to do is I'm going to divide both sides by 3. And I get that absolute value of x plus 7 equals 7. So now is my absolute value expression all by itself? Yes. And now I can split it into my 2 equations. So I can split it so I have x plus 7 equals positive 7, and then x plus 7 equals negative 7. So now that I have my 2 separate equations, and notice when I split it into my 2 separate equations, the absolute value symbols go away. Now I can actually start to solve for x. So I would subtract 7 from both sides for my first one. And I get x equals, well, 7 minus 7 is 0. So that's one of my solutions. Subtract 7 from both sides, and I get x is equal to negative 7 minus 7 is negative 14. So my 2 solutions here are 0 and negative 14. Okay, last example problem of the unit, because this is our last section before we test. So the last problem here, again, we want to get the absolute value expression all by itself. So we have 3 plus the absolute value of x minus 4. So this is a positive 3. So to move it to the other side, I want to subtract 3 from both sides. And I get the absolute value of x minus 4 equals negative 3. Now, remember what I was saying up above. All of these absolute values equal a positive number, because that's what we know. An absolute value expression is always equal to a positive number. This one is equal to a positive 12, a positive 2, a positive 7, a 34, a positive 17, but this one's equal to a negative 3, so we have to stop and think. Is there a way that an absolute value expression will equal a negative number? Does distance ever equal negative? No. And so what this means, because an absolute expression will never equal a negative number, what this means is there is no solution here. So when you isolate, if you isolate the absolute value expression and it's equal to a negative, you need to stop and it's no solution. So you got to think about this. So an absolute value in expression, an absolute value expression will never equal a negative number. There is no possible value I can plug in to x that will get like something that's negative. And that does it. So always check those. Always make sure that your absolute value expression equals a positive number before you split it. Okay, so if you guys have any questions, make sure you guys bring them to class so we can go over them. And that is it for the notes today. Have a great day, and I will talk to you guys soon. Bye, guys.